Enterprises need a way to control what AI agents can access, what they can do, what tools they can use, and how their actions are tracked. Indicate Agent Control provides that layer of control. It helps organizations govern AI agents with clear policies, visibility, and traceability. Here's how it works. In this demo, we are looking at CanBank, a fictional retail bank. CanBank has deployed AI agents to help improve customer support. We've got a chatbot and 2 agents deployed, an orchestrator agent and a retriever agent. Each of these agents is protected by our Agent Gateway service. The retriever agent uses the Indicate MCP server to answer questions about CanBank. This demo will walk through the agentic workflow to show how the gateway validates the entire calling chain, from the original requester to each agent involved, to ensure the request is authorized before it can proceed to the next agent. Before we get started, let's take a look at some of the data in the Indicate platform. Here we have the customer, Ted. Ted has 2 CanBank accounts, an investing account and a credit card account. Both are Tier 3 accounts. We can see that Ted created a support ticket that was closed by a decision made by Flo Collins, who was a customer service rep at the time. That decision was an exception to the refund policy. The refund policy document came from SharePoint and is in the customer service policy folder, which the customer support department can access. We can also see the user, Flo Collins, came from Workday. Flo has a trust score, which is calculated by the Indicate platform. The trust score allows the enterprise to score the risk of different dimensions of their data, and that risk can then be included in decisions made by the platform. Flo has a direct report, Leslie, who also works in the same department. Leslie is a customer service rep. Okay, now we're going to walk through an agentic customer service workflow. The customer, Rebecca, has called in and complained about her credit card statement because she noticed an overage charge due to a late payment. She is a good customer and wasn't very late, so she'd like to try and have this penalty reversed. She talks to support officer Leslie. Leslie logs into the chatbot to see if he can gain any additional insights into refunds in order to better handle the request. Here we are using Curity as the IDP, but Indicate works with any third-party IDP that supports token exchange. Leslie is now logged in. The chat interface will pass requests from Leslie to the agents that will perform work on Leslie's behalf. Included in the chatbot is an audit terminal that shows the gateways handling the agentic flow. You can see that when the gateway gets a request, it checks a token and then determines whether or not to let the request proceed. On the far right-hand side of the screen, you can see the Docker log for the retriever agent. When the retriever agent handles requests or receives responses, they're visible here. This is very important for traceability and understanding of agentic activity for audit and compliance purposes, but also for adding organizational intelligence and understanding how agents are performing workflows. Leslie says hello to begin his interaction. With this hello, the Indicate orchestrator gateway retrieves the token information and checks to see whether Leslie is authorized to call the orchestrator agent. It checks to see what workflow the agent is part of, and finally, checks to see whether the subject, Leslie, can indeed call that workflow. As a customer service representative, Leslie can trigger the workflow one, so we're good to proceed. Leslie asks what policy documents pertain to refunds. Here is where we tap into the power and intelligence of the contextualized data model. The gateway intercepts the request and checks to see whether Leslie can call Agent 1 and Agent 2. In this example, both the orchestrator gateway and the retriever gateway are triggered. The question made it through the retriever gateway to the retriever agent. The retriever agent then posed a series of questions to the Indicate MCP server. The dialog is visible in the retriever agent Docker log on the far right hand of the screen. The MCP server returned a list of resources to the retriever agent. The retriever agent then called one of its tools, the Context IQ Executive tool, which contains a query to find documents that have a document type of refund policy. The agent found the document and returned the information. As you can see, the policy document pertaining to refunds is named Customer Refund Policy and can be found here. The agent provides the SharePoint link to the document, drastically speeding up the process for the customer service rep, Leslie. Leslie now wants to know whether this document has been used in any past decisions. He types, "Retrieve the past decisions that incorporated the refund policy document." The agent repeats the process. The request starts with the orchestrator, and the orchestrator passes it on to the retriever. With this query, the retriever side shows a lot of activity. It gets the resources back, it finds a query for use and understanding of past decisions. The agent found a past decision that incorporated the refund policy document. The agent has provided more intelligence for Leslie to act upon. There was a similar case at CanBank, where Flo Collins, another customer service rep, waived the late payment charge for Ted Lasso because Ted was a loyal customer and did not have any other late payment charges. Flo was concerned that Ted was at risk of leaving CanBank over the late payment charge. With this additional information and precedent, Leslie is going to proceed with crediting Rebecca back with the amount. Leslie will then go into the Salesforce system and close the ticket and update it with the document and all details that were used to render the decision. Every update Leslie has made will flow back down into the IndyKite context graph, providing more history and intelligence to draw on for the next time decisions have to be made. As decision context gets added to the graph over time, agents will be able to tap that intelligence to ultimately support fully autonomous decision making.